Okay, the last inverse trig function we'll look at is inverse cosine, also found in section 6.5. Here is the graph of y equals the cosine of x. Now, we cannot do the same thing with cosine that we did with sine and tangent. If we restrict the domain between negative pi over 2 and positive pi over 2, it's still not going to be a one-to-one function. You can see it fails the horizontal line test. If I draw a horizontal line, it'll hit at more than one point. So we're going to restrict the domain in a different way. The way we're going to do it is we're going to restrict it from 0 to pi. All right, so we'll only use from the point that's at 0, 1 to the point that's at pi negative 1. Okay, so if you only use this much of it, you can see part of it has positive cosine values and part of it has the negative cosine values. So all the values of cosine will be accounted for one way or another. So here's what it will look like. All right, so it starts at the point 0, 1, it goes through the point pi over 2, comma 0, and then finishes at pi, comma negative 1. All right, now if you take all of these points and reverse the x and y coordinates, the inverse function is going to have a point at not 0, 1, but 1, 0. It's going to go through the point 0, comma pi over 2, and it'll go through the point negative 1, comma pi. All right, and then it will look like this. All right, so this point up here is negative 1, comma pi. It goes through the point 0, comma pi over 2, and then it finishes at the point 1, comma 0. All right. So for the inverse cosine or the arc cosine, the domain is going to be negative 1 to 1, and the range, this is the new part for cosine, is from 0 to pi. All right. This is what's different for cosine, inverse cosine, compared to inverse sine and inverse tangent. So if you are doing problems where you're using special angles and special values, all right, inverse cosine, since it is between 0 and pi, you will only be using quadrants 1 and 2 on the unit circle. Okay, you won't be using the bottom half. Okay, so if you're doing an inverse cosine problem with an exact value and your answer's in radians, these are the only possible answers that you might have. 0, pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, or pi. That's it. All right. Now, if you're working something out in degrees, right, then you might have these answers. 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees, 120 degrees, 135 degrees, 150 degrees, or 180 degrees. So it's a very limited answer bank. Okay, so just a couple quick examples. If you're supposed to find the arc cosine of the square root of 2 over 2, you're trying to find the angle whose cosine is equal to the square root of 2 over 2, and the angle is between 0 and 2 pi. So if you are thinking about the unit circle, all right, at pi over 4, that's where the x coordinate is root 2 over 2. All right. So if you're answering it in radians, you would say pi over 4. If you're answering it in degrees, you would say 45 degrees. Just look at the directions of where you're working. All right. One other example. If you're doing the inverse cosine of negative root 3 over 2. Again, you're trying to see what angle has a cosine value of negative root 3 over 2 and is between 0 and pi. You always have to deal with that when you're doing with inverse cosine. Okay, so the angle whose cosine is negative root 3 over 2 is over here in the second quadrant, right? and it corresponds with this point right here. That's where the x-coordinate is negative root 3 over 2. So in radians, the answer would be 5 pi over 6. In degrees, it would be 150 degrees.